The United Kingdom's Joint Combat Aircraft program was born out of a pressing need. The military had to replace the aging Harrier fleet. Since the 1960s, the Harrier had been the go-to tactical aircraft for both the Royal Air Force and the Royal Navy, handling close air support and carrier-based defense. But by the late 1990s, the Harrier GR7 and GR9 variants were being pushed to their limits. They were becoming obsolete, plagued by outdated electronics, aging engines, and worn-out airframes. Maintenance costs were skyrocketing, especially after the fleet was downsized following the 1998 Strategic Defense Review. The goal of the new program was simple but ambitious. They needed to restore a unified combat air fleet that could seamlessly operate from both land bases and future aircraft carriers, adapting to the post-Cold War era of global deployments. A major requirement for this new aircraft was the ability to perform short takeoffs and vertical landings. This was essential for operating from the upcoming Queen Elizabeth-class carriers, which were announced in 2007 to replace the older Invincible-class ships by 2015. When the Sea Harrier FA-2 was retired in March 2006, the Royal Navy lost its carrier air defense. This made finding a replacement incredibly urgent. They needed a jet that could handle precision strikes, reconnaissance, and take out enemy air defenses, all without using traditional catapults or arresting cables. This vertical landing requirement came down to basic operational reality. British carriers had smaller decks and fuel limits that made conventional takeoffs impossible. Plus, vertical landing allowed for rapid deployment in tough conditions, something that had been proven decades earlier during the Falklands War. When the Royal Air Force retired its own Harriers in 2010, the rush to get the Joint Combat Aircraft ready became even more intense, aiming to create one unified fleet and cut down on duplicate training and logistics. The overarching defense strategy focused heavily on working alongside NATO allies, especially the United States. In 1995, the UK joined the American F-35 program as a Tier 1 partner. This gave them a voice in the aircraft's design and access to its cutting-edge technology. To survive against modern enemies armed with advanced air defenses and long-range missiles, the military needed fifth-generation stealth, smart sensor fusion, and networked warfare capabilities. The old, non-stealthy, subsonic Harrier just could not survive in that environment anymore. The 2010 National Security Strategy confirmed that projecting power from aircraft carriers was vital for the country's global influence. Initially, they demanded at least 50 of these new aircraft to maintain 2 active carrier strike groups, though that number was later adjusted due to budget cuts. The main priority was pure combat effectiveness, achieving total air superiority and strike capability in the most dangerous environments, rather than just protecting local industry, even though the partnership with Lockheed Martin still supported many British jobs. The Harrier's proven success in island and amphibious campaigns deeply influenced this massive strategic shift. However, the new aircraft needed to do much more. It required a larger payload, a range of up to 1,150 miles while carrying internal weapons, and true stealth capabilities. This would allow the new jet to work perfectly alongside the Eurofighter Typhoon. After the operations following September 11th, military leaders realized the Harrier's limitations when it came to endurance and precision against heavily defended targets. This created an absolute need for internal weapon bays and advanced sensors, ensuring the new aircraft could maintain a lethal edge in long-range, beyond visual range combat. The competition for what became the Joint Combat Aircraft program began in the mid-1990s under the Future Carrier-Borne Aircraft designation. It focused on procuring a multi-role successor to the Royal Navy's Sea Harrier for aircraft carrier operations. Following the 2001 expansion to include the replacement of the Royal Air Force's Harrier GR7 fleet, the initiative was renamed the Future Joint Combat Aircraft. The UK Ministry of Defence evaluated several candidate aircraft, including European options, but they prioritized working seamlessly with United States-led programs. On January 17, 2001, the JSF was identified as having the strongest potential to meet the project specifications. This prompted an agreement with the U.S. Department of Defense to join the JSF system development and demonstration phase. UK representatives were directly involved in the JSF evaluation, which pitted the Boeing X-32 against the Lockheed Martin X-35 demonstrators. They looked closely at criteria like cost, performance, and suitability for short takeoffs and vertical landings. Lockheed Martin emerged victorious on October 26, 2001, securing the prime contract. The F-35B short takeoff and vertical landing configuration was selected to perfectly align with the UK carrier-based requirements for their forthcoming Queen Elizabeth-class vessels. The United Kingdom actually entered the Joint Strike Fighter program as a full collaborative partner through an agreement signed back in December 1995. Initially, they focused on the concept exploration phase to assess potential aircraft designs for replacing their aging Harrier and Tornado fleets. As the sole Level 1 partner, the UK committed approximately $2 billion to the program's system development and demonstration phase, starting in 2001. This investment gave them significant influence over the requirements, especially for the vertical landing variant prioritized for their carrier operations. Formalized through a January 2001 agreement with the U.S. Department of Defense, this positioned the UK to integrate its industrial base. For example, BAE Systems contributed to critical subsystems like the rear fuselage and electronic warfare systems. The UK's formal selection of the Lockheed Martin F-35 Lightning II for the Joint Combat Aircraft requirement followed the program's 2001 down-select to the X-35 demonstrator. This choice aligned closely with the 1998 Strategic Defense Review, which emphasized carrier-enabled power projection. Initial commitments included plans for up to 150 F-35B aircraft. However, early purchases were put on hold while waiting to resolve technology transfer disputes. These commitments were provisional because the UK hesitated to fully endorse the production and sustainment phases. This was due to strict U.S. restrictions under the International Traffic in Arms Regulations, or ITAR, on exporting sensitive technologies. The British military specifically needed access to software source code and mission data processing tools, which were essential for independent upgrades and keeping their operational sovereignty intact. Technology transfer negotiations ramped up after 2001. The UK pushed for access to enable domestic sustainment without being perpetually reliant on the United States, citing risks to their operational independence in contested areas. A significant development occurred in December 2006 when the US and UK inked an agreement for a limited technology release concerning the F-35B. This package included the essential tools for maintenance and modifications, which was sufficient to move forward with initial production commitments. At the same time, it maintained U.S. control over core classified elements like the ALIS logistics system. Formalized under a broader U.S.-UK defense trade initiative, this accord allowed BAE Systems to produce over 10% of each airframe and acquire the classified data necessary for integration. Nevertheless, reports in 2009 highlighted U.S. hesitation to fully relinquish software sovereignty, underscoring the ongoing complexities in bilateral technology sharing. The UK Ministry of Defense signed an agreement for the F-35 fighter program in 2006. This decision was part of a strategy to replace their aging Harrier and Tornado aircraft. Deliveries of the first F-35B jets for Britain commenced in 2012. Initially, these aircraft were utilized exclusively for testing and evaluating their capabilities. Following a defense strategy review in 2010, the program zeroed in on the F-35B variant. These are short takeoff and vertical landing aircraft, a perfect fit for the Queen Elizabeth-class carriers with their ski jump ramps. They opted against conventional carrier-based fighters at that time. In July 2011, the ministry placed an order for the first 4 jets, including one designated for training. They arrived at Royal Air Force Base Marham in June 2018 and were assigned to the 617th Squadron. By December 30, 2018, it was announced that they had achieved initial combat readiness operating from land bases. Due to budget constraints, purchases were made in stages. The core of the initial fleet was slated to comprise 48 F-35Bs. By mid-2025, Britain had taken delivery of 38 aircraft. The final jet of this batch is anticipated no earlier than April 2026, owing to production delays. Full combat readiness, originally projected for 2025, remains elusive. This is attributed to challenges with the aircraft's technical condition, a personnel shortage that could persist until 2028, along with delays in equipment upgrades and the integration of long-range precision munitions. In June 2025, plans underwent a significant revision. The ministry decided to procure at least 12 F-35A aircraft, which feature conventional takeoff and landing. This move was essential to support NATO nuclear deterrence missions. Consequently, Britain shifted away from the concept of relying solely on the B variant, favoring dual-purpose land-based aircraft expected to be operational by 2030. In total, the country intends to acquire 138 of these fighters. Their service life has been extended to 2069, although they were initially scheduled for retirement in 2048. However, escalating costs and maintenance issues have somewhat diminished the initial appeal of this program. As of July 2025, the Royal Air Force and Navy already fielded 37 of these aircraft. This has substantially bolstered their combat capabilities, notwithstanding the maintenance hurdles. The new F-35A aircraft will be stationed at Marham. Compared to the B variant, they boast a longer operational range and can carry a greater payload. This significantly broadens the multi-role capabilities of British air power. Plans are in the works to grow the fleet to 74 aircraft by 2033, though as of October 2025, there's no contract yet for the second batch. The Ministry of Defense aims for the first batch to be fully combat ready by the end of 2025. They intend to showcase this during the deployment of a carrier strike group featuring 24 F-35B Lightning II fighters. This multifaceted approach to fleet composition helps them better address new strategic challenges, even as the program continues to face criticism for budget overruns and schedule delays. The F-35B Lightning II, which Great Britain selected as its primary combat aircraft, is a single-seat, single-engine, fifth-generation stealth fighter. It was developed by Lockheed Martin to handle a wide array of missions. The aircraft's design renders it nearly invisible to radar thanks to its specially shaped airframe, radar-absorbent materials, and internal weapons bays. The airframe is constructed from modern composite materials and alloys, making it both strong and lightweight. This allows it to maintain supersonic speeds without engaging afterburners. The core of the aircraft is the Pratt & Whitney F135 turbofan engine, producing over 40,000 pounds of thrust. It strikes an excellent balance between power and agility. The engine incorporates a specialized exhaust system designed to maintain the aircraft's stealth profile, while its modular design enhances reliability and simplifies maintenance. The fighter can accelerate to Mach 1.6 at high altitudes, and its service ceiling surpasses 50,000 feet. This enables it to effectively intercept targets and conduct airstrikes. Key aerodynamic features include diverterless supersonic inlets, which improve airflow and reduce the aircraft's radar signature. The canted vertical stabilizers aid in flight control and also contribute to its stealth capabilities. From the outset, designers prioritized integrating data from all sensors. The compact fuselage houses efficient systems that allow the aircraft to remain airborne for extended periods, making it ideal for operations from both conventional airfields and aircraft carriers. All these elements empower the F-35B to operate with confidence in heavily defended enemy airspace. The fighter's primary sensor is the AN/APG-81 radar from Northrop Grumman. It operates in multiple high-resolution modes, tracking aerial targets and performing electronic warfare. The radar can detect enemy fighters from over 150 nautical miles away. Supporting this is the AAQ-40 electro-optical targeting system, which combines infrared cameras and lasers for precision strikes against ground targets. All this equipment is concealed within the airframe, ensuring it doesn't compromise the jet's stealth characteristics. Another system, the AN/AAQ-37, comprises 6 cameras providing a full 360-degree infrared view. It detects incoming missiles from any direction, assists with fire control, and transmits night vision imagery directly to the pilot's helmet. On the British F-35B, all these systems function as a cohesive unit, managed by a powerful central processor. This processor handles over 1.7 million lines of code, aggregating data from the radar, cameras, and electronic intelligence systems. This information is synthesized into a single, unified battlefield picture, displayed to the pilot on a large panoramic screen. Consequently, the aircraft can simultaneously engage in air-to-air combat, strike ground targets, and act as a scout. For the British Navy and Air Force, the aircraft is equipped with the Link 16 communication system for real-time data exchange. Additional classified British programs will be integrated during the Block 4 upgrade, scheduled to run until 2029. When it comes to weaponry, the F-35B prioritizes internal carriage for maximum stealth. It features 2 internal weapon bays capable of holding 4 AIM-1 20 AMRAAM missiles, or a mix of 2 AMRAAMs and 2 ASRAAM air-to-air missiles for air superiority missions. For ground targets, UK forces can load 2 GBU-32 JDAM or Paveway 4 guided bombs. For close air support, there's a conformal 25mm GAU-22A cannon pod packed with 180 rounds. When stealth isn't the top concern, 6 external hardpoints can carry up to 15,000 pounds of ordnance. This allows for the integration of British weapons like the Storm Shadow cruise missile, though full certification is still pending. Trials for the MBDA Meteor long-range missile kicked off in March 2025, but software and testing delays have pushed its full integration from 2027 to the early 2030s. The Spear 3 strike missile and other standoff weapons are also facing similar delays into the 2030s. Because of this, the military is exploring interim solutions like small diameter bombs for precision ground attacks. As of October 2025, British F-35B fighters are primarily relying on American munitions while they work through the challenges of integrating their own weapons systems. The F-35B variant is unique for its short takeoff and vertical landing capabilities. This sets it apart from the standard F-35A and allows it to operate from the UK's Queen Elizabeth-class aircraft carriers without the need for catapults or arresting gear. This vertical lift system incorporates a shaft-driven lift fan located just forward of the cockpit, powered by the Pratt & Whitney F-135 engine. This fan provides about 40% of the vertical lift. It works in conjunction with the engine's exhaust nozzle, which can pivot straight down up to 90 degrees, along with roll posts under the wings to maintain the aircraft's stability. This design addresses many issues found in older vectored thrust aircraft like the Harrier. Now, pilots can take off rapidly, fly at supersonic speeds, and land vertically with confidence, even when carrying a full weapons load. It's a groundbreaking achievement, combining stealth, speeds exceeding Mach 1, and vertical landing capabilities into a single mission profile. In British service, the short takeoff and vertical landing ability means the F-35B can operate from austere, concealed locations, including highways and temporary airfields. This significantly enhances the aircraft's survivability against advanced adversaries, as it's not reliant on traditional fixed airbases. The Royal Navy and Royal Air Force are even planning demonstrations of these highway landings to showcase the jet's operational flexibility with minimal ground support. This capability makes it the direct successor to the Harrier GR9, but with a monumental leap forward. Unlike the Harrier, the new jet boasts stealth and can maintain high speeds, providing the United Kingdom with potent, persistent air support from the carriers HMS Queen Elizabeth and Prince of Wales. As a multi-role fighter, the F-35B is packed with advanced electronics. It can handle air-to-air combat, precision strikes, surveillance, and electronic warfare all at the same time. This is made possible by a system called sensor fusion. It takes data from the radar, targeting cameras, and sensors all around the aircraft and blends them into one clear, easy-to-read picture of the battlefield for the pilot. British versions get specific software updates to help integrate national weapons like the MBDA Meteor and Storm Shadow missiles. During complex missions, the internal weapon bays keep the aircraft stealthy and hard to spot. But in skies where enemy anti-aircraft threats are low, Those external wing pylons offer huge flexibility for carrying heavy ground attack payloads. Even just running on internal fuel, the jet boasts a combat radius of more than 450 nautical miles. The multi-role versatility of the aircraft is amplified by the F-35B's network-enabled operations. This allows for real-time data sharing with allied aircraft, like the Eurofighter Typhoon, during combined missions. We have seen this demonstrated in exercises stretching from the Mediterranean to the Indo-Pacific regions. This adaptability supports the integrated force structure of the United Kingdom, meaning a single squadron can shift seamlessly between carrier strikes, coastal maneuvers, and homeland defense without needing to reconfigure. Royal Air Force Marham in Norfolk was chosen as the primary operating base for the F-35B Lightning II aircraft back in 2013. Since then, the base has seen massive upgrades to handle these fifth-generation stealth fighters. In October 2017, they finished resurfacing the runway intersections to safely support the heavier F-35B platforms. They also built specialized hangars, maintenance facilities, and new housing for personnel. This ensures full support for operational teams like No. 617 Squadron, as well as training units like No. 207 Squadron. By 2025, Marham hosts the vast majority of the F-35B fleet, with continuous investments in engineering to keep the aircraft ready for action. Out at sea, the Queen Elizabeth-class carriers, HMS Queen Elizabeth and HMS Prince of Wales, provide the core infrastructure for deployments. From day one, these ships were designed specifically for short takeoff and vertical landing operations. Equipped with 12-degree ski jump ramps and reinforced flight decks built to handle the intense heat of vertical landings, each carrier can support up to 36 aircraft at maximum capacity. However, a typical carrier strike group usually deploys with 24 F-35Bs. Because the ships were built with the future in mind, no major retrofits were needed. They already have the power infrastructure to support electromagnetic aircraft launch systems, even though they currently focus on vertical landings and do not use catapults. In 2025, HMS Prince of Wales led Operation Highmast, bringing aboard aircraft from No. 809 Naval Air Squadron alongside Royal Air Force assets, proving that integrated basing works perfectly for multinational exercises. When it comes to training, Joint Combat Aircraft pilots primarily go through No. 207 Squadron. Based at Marham, this operational conversion unit provides joint instruction for both the Royal Air Force and the Royal Navy. They teach everything from short takeoff and vertical landing maneuvers to advanced mission tactics. The squadron was specifically reformed for this role and started training activities when the first F-35Bs arrived in the United Kingdom in 2018. Their main focus has been taking experienced Harrier and Typhoon pilots and getting them up to speed on this highly advanced platform. On the operational side, you have No. 617 Squadron. This was the first frontline unit reformed in April 2013, specifically to fly the F-35B. They flew their first operational missions in June 2019, supporting coalition efforts. Then there is No. 809 Naval Air Squadron, the Royal Navy's very first F-35B formation, which was officially stood up in 2023. This gave the Navy dedicated maritime strike capabilities and the ability to seamlessly run joint operations with the Air Force. Both of these squadrons share the base at Marham, and their personnel are cross-trained to integrate perfectly with the aircraft carriers. The Ministry of Defense declared initial operating capability for land-based operations in December 2018. This meant that No. 617 Squadron was finally ready to take on limited combat tasks, even while some infrastructure and software upgrades were still being ironed out. Carrier strike capability followed shortly after in January 2021. This came after extensive trials, including the historic first F-35B deck landings on HMS Queen Elizabeth in September 2018, and exercises that proved the aircraft could perform rolling vertical takeoffs and landings at sea. While this milestone successfully integrated the aircraft with the new carriers, getting the full squadrons fully operational did face some delays. For example, the initial capability for the 2nd Frontline Unit had to be pushed back to December 2024 because of engineering challenges. The integration of F-35B Lightning II fighters with the Royal Navy Queen Elizabeth-class aircraft carriers began with trials on the lead ship in 2018. At that time, a dedicated test group successfully executed short takeoffs and vertical landings. These efforts continued on the aircraft carrier Prince of Wales, where F-35B landings were recorded on October 11, 2023, during operations in the Western Atlantic. By 2025, these carriers proved their ability to carry up to 36 of these fighters alongside helicopters. This provided high flexibility in combat zones thanks to short takeoff and vertical landing technology. F-35B squadrons from the Royal Air Force's 617 Squadron and the Royal Navy's 809 Naval Air Squadron took part in multinational exercises during the Carrier Strike Group deployment in 2025. In July of that year, American F-35Bs from the United States Marine Corps landed on the deck of Prince of Wales ahead of the Talisman Sabre exercise. This allowed them to practice interoperability in the Pacific Ocean and confirm Allied capabilities. Additional operations included joint activities with the Japanese and American fleets. For example, formation flights with F-18E Super Hornet fighters over the Pacific and landings on Japan's largest warship. This highlighted the role of these aircraft in regional deterrence. Such actions strengthened cooperation with NATO and partners, and the deployment itself proved the effectiveness of island-hopping tactics and 5th-generation power projection. Operational deployments reached their peak during Operation High Mast in April 2025. At that time, HMS Prince of Wales led a multinational task force that transited the Mediterranean Sea on its way to the Indo-Pacific region. The voyage lasted until December, and on board were about 16 F-35B fighters from the British fleet, which in total comprised 35 such aircraft. The mission brought together over 4,000 service members from the Royal Navy, the Royal Air Force, and the British Army, as well as allies from Canada, Norway, Spain, and New Zealand. The main goal was to achieve full operational capability at sea, while simultaneously conducting intelligence, surveillance, and strike missions. Despite some maintenance challenges, the deployment showed that F-35Bs can operate long and effectively from aircraft carriers in forward areas like the South China Sea. This became the second major deployment of a British carrier strike group. The Joint Strike Fighter program significantly strengthens Great Britain's deterrence potential. It provides the country with a stealth, 5th-generation fighter capable of penetrating modern air defense systems. This makes British aviation a serious threat to any adversary. Such capabilities support NATO commitments and allow for independent operations, especially in regions where fixed bases might be under threat. The integration of F-35B fighters with Queen Elizabeth-class aircraft carriers allows for the rapid deployment of air forces from their own territory. This ensures strong power projection without the need to rely on the infrastructure of other countries, which could be vulnerable to preemptive strikes. Among the major operational achievements was reaching initial operating capability in January 2021. This marked the first time the F-35B aircraft were deployed combat-ready alongside the Royal Air Force and the Fleet Air Arm. By July 2025, there were already 37 of these aircraft in service. This was a massive leap in strike and reconnaissance capabilities compared to legacy platforms like the Harrier. The 2025 Carrier Strike Group deployment, led by HMS Prince of Wales, hit a peak rate of 16 combat sorties in 24 hours. This showed a high operational tempo and excellent interoperability with allied forces from over a dozen nations. These maneuvers proved the success of island-hopping tactics and multinational integration, showing that the program plays a key role in strengthening collective security and alliance cohesion. Getting confirmation of operational independence in March 2025 was huge. It was made possible by their Tier 1 partner status, which gave them access to the source code. This ensures the United Kingdom can maintain and upgrade its fleet without relying on anyone else, really boosting their long-term strategic autonomy. These milestones have made the F-35B the cornerstone of carrier strike. Full operating capability is just around the corner, and these ongoing deployments send a strong message about their defense commitments to both partners and potential adversaries. The Joint Combat Aircraft Program, which includes both the F-35B and F-35A variants, forms the backbone of the United Kingdom's defense posture as outlined in the 2025 Strategic Defense Review. It enhances air superiority, precision strike, and deterrence against near-peer adversaries by integrating with both naval and land-based forces. This capability supports NATO's first policy, allowing for rapid deployment in the Euro-Atlantic and Indo-Pacific theaters. The F-35s are also contributing to integrated air and missile defense, right alongside Typhoon aircraft. As of June 2025, 37 F-35s are operating across 2 squadrons, bringing stealth, sensor fusion, and data-sharing superiority that legacy platforms like the Harrier and Tornado just could not match. Central to all this integration is the role of the F-35B in carrier-enabled power projection. It equips the Queen Elizabeth-class carriers with hybrid air wings that include uncrewed systems and long-range munitions for sustained operations. The Royal Navy Carrier Strike Group hit a peak sortie rate of 16 launches in 24 hours during their 2025 exercises. This really demonstrated their interoperability with NATO allies during multinational drills and deployments to regions like Japan and Australia. Full operating capability for the UK's F-35 force is targeted for late 2025. This lines up perfectly with the global missions of the Carrier Strike Group, projecting power and reinforcing alliances under frameworks like AUKUS and the Lancaster House treaties. The 2025 acquisition of 12 F-35A aircraft for the Royal Air Force brings in a dedicated land-based element. These jets can deliver both conventional and sub-strategic nuclear strikes using the B-61-12 bomb. This complements the Trident nuclear deterrent and bolsters the NATO nuclear sharing posture against threats from Russia. This dual-variant approach, the F-35B for joint Royal Air Force and Royal Navy carrier operations, and the F-35A for agile basing, really facilitates multi-domain warfare. There are plans to expand the fleet to meet the Strategic Defense Review commitments for increased lethality and endurance by 2035. And finally, interoperability with U.S. and allied F-35 fleets ensures seamless data fusion in coalition operations, which we saw firsthand with the joint launches from Japanese carriers in August 2025. Future evolution ties the Joint Combat Aircraft to the Global Combat Air Program, a 6th-generation successor developed with Italy and Japan, ensuring continuity in UK air power while the F-35 bridges to autonomous systems and digital targeting networks. This strategic layering addresses fiscal constraints by prioritizing high-impact assets, with UK industry contributing approximately 15% of each F-35's value, sustaining over 3,500 jobs and export potential. Overall, the Joint Combat Aircraft elevates the UK's contribution to collective defense, enabling deterrence through credible, tech-enabled forces amid rising global tensions. The United Kingdom's F-35 Lightning II program, specifically using the F-35B variant, has experienced significant cost overruns when compared to early projections. The National Audit Office reported that the Ministry of Defense had spent £11 billion by mid-2025. This figure easily surpassed the financial benchmarks established back in 2013. Current estimates predict the program's total lifetime costs, including aircraft acquisition, maintenance, personnel, and basing, will reach £71 billion by 2069, for a planned fleet of 138 aircraft. This represents a substantial increase from the initial projection of just £18.76 billion solely for purchasing the aircraft. The escalating costs are attributed to higher individual aircraft prices, procurement delays due to budget constraints, and insufficient consideration of long-term expenses in the original planning. The acquisition of these jets has been hampered by budget limitations and technical challenges since the first deliveries in 2010. Consequently, there is no firm timeline for receiving the remaining 101 aircraft, beyond the 37 F-35B jets that have been delivered by July 2025. Upgrades to both hardware and software have fallen behind schedule, consequently delaying the jet's full combat readiness. For instance, the integration of the Spear 3 missile, initially slated for late 2024, has been postponed into the 2030s. The Meteor long-range missile faces similar delays. These setbacks are exacerbated by global supply chain issues. In 2024 alone, deliveries were delayed by an average of 238 days per aircraft. This has severely restricted fleet expansion and postponed planned demonstrations for aircraft carrier strike groups scheduled for 2025, which were intended to showcase up to 24 jets. Achieving operational readiness for these aircraft presents another major obstacle due to low availability rates and a lack of adequate support. Currently, the full mission availability rate for the F-35B fleet stands at approximately 16%. This signifies that, at any given time, only about 1 in every 6 jets is prepared to execute all assigned combat missions. This situation stems from complex maintenance requirements, incomplete software development, and a shortage of engineering personnel. Auditors indicate that the current combat capability falls significantly short of the expectations set in 2013. This deficit is projected to persist for several years, with staff shortages anticipated to continue until 2028, alongside ongoing delays in logistics and technology updates. Despite the jets having been utilized in limited military exercises, these ongoing challenges have resulted in what the National Audit Office describes as a disappointing return on the investment made to date. The F-35B's capability for short takeoff and vertical landing is accompanied by inherent technical trade-offs. For example, it has a reduced internal fuel capacity. It can carry approximately 18,250 pounds of fuel, slightly less than the F-35A's 18,498 pounds. This limitation impacts the jet's combat range and its endurance during naval operations. These constraints are a direct result of the Rolls-Royce lift system integrated into the aircraft. This system occupies valuable internal space and adds approximately 1,000 pounds of extra weight compared to other F-35 variants, thereby reducing its ordnance capacity during aircraft carrier missions. Despite its advanced stealth features and highly sophisticated sensors, persistent issues with software and hardware have delayed critical system enhancements, such as the Block 4 modifications. This directly affects sensor performance and the jet's ability to reliably process data when operating in hostile environments. Logistical problems are largely tied to inefficient maintenance. As of mid-2025, the combat readiness level of British F-35B fighters lagged behind global averages. Only about 33% of the aircraft were fully ready for combat missions. This happened because of long maintenance cycles, which average over 30 hours for every flight hour, as well as a chronic shortage of spare parts. Relying on a global support system managed by Lockheed Martin makes the program vulnerable to disruptions in international supply chains. There are delays in buying specialized parts, like engine lift fans and electronic modules. To make matters worse, there's a domestic shortage of about 20% when it comes to qualified engineers. Because of these issues, it still hasn't been possible to integrate key British weapons, specifically upgraded versions of ASRAAM missiles. This limits the aircraft's combat capabilities until new software updates are certified, which could drag on into 2026. Deployment incidents only highlight these weak points. For example, in August 2025, a Royal Navy F-35B fighter was grounded in Japan for over a week, waiting for spare parts after an in-flight technical failure. Similar hydraulic system failures left aircraft stranded in India in June 2025. Equipment had to be airlifted in to repair them. This clearly shows how risky it is to deploy aircraft to forward bases without reliable organic logistics. The Ministry of Defense has taken temporary steps like stockpiling critical parts at Royal Air Force Base Marham and expanding contractor support. However, the National Audit Office warns that without quickly hiring new specialists and diversifying supplies, these shortcomings could weaken the country's defense capabilities amid growing global threats. Following the 2010 Strategic Defense and Security Review, which required retiring the Royal Navy's Sea Harrier and Harrier GR-9 fleets by December 2010, discussions began. The question arose of how to restore carrier strike power without being tied to the F-35B Lightning II. Alternatives included retrofitting Queen Elizabeth-class aircraft carriers with a catapult launch and a resting gear system. This would allow the use of conventional takeoff aircraft like the Boeing F-18 Super Hornet or the Dassault Rafale M. However, this would require major design changes, costing between 2 and 5 billion British pounds, and would lead to years of delays. Supporters of this idea argued that using proven aircraft would reduce maintenance costs and provide greater flexibility in weapon selection, completely avoiding the risks of developing the new F-35. Critics, however, noted that because of the ski jumps on the aircraft carriers and the fleet's overall doctrine, which focused on short takeoff and vertical landing aircraft, these changes would be impractical and far too expensive. Ultimately, in 2012, the Ministry of Defense made its final choice in favor of the F-35B, rejecting the conventional F-35C version. The main priority became interoperability with American forces and NATO allies, rather than choosing independent European variants. Current discussions highlight the strategic dependence of the F-35B on the United States. Great Britain does not have full control over the aircraft's software, its diagnostic system, and the supply chain for critically important components like engines and sensors. As a Tier 3 partner in the Joint Strike Fighter program, Great Britain assembles the aft fuselage sections and wings at BAE Systems factories, but relies on Lockheed Martin for Block 4 upgrades and technologies that are subject to export controls. This raises concerns about combat autonomy in the event of a change in American policy or geopolitical tension. A July 2025 report from the National Audit Office highlights these vulnerabilities. It notes that the 37 F-35B fighters delivered by that time were experiencing delays in integrating specific British munitions, like Spear 3 and Meteor. Consequently, they temporarily had to use less effective weapons, which reduces overall combat readiness. Critics, referencing analysis from Chatham House, contend that this reliance weakens deterrence capabilities. It links British strike missions to American approvals and technical support, potentially limiting independent actions in high-threat scenarios. Further discussions focus on long-term solutions to reduce dependencies, such as expediting the Global Combat Air Program, previously known as Tempest, to develop a 6th-generation successor, or acquiring more Eurofighter Typhoons for interim land-based roles. However, the projected entry into service for the program after 2035 creates a capability gap, and the Typhoon lacks the stealth and advanced sensor fusion of the F-35B for aircraft carrier operations. Supporters of diversification argue for joint European development to lessen reliance on the United States. They cite practical risks such as American export restrictions imposed by past administrations, even though data from NATO exercises shows the F-35 works seamlessly with Allied forces, enhancing deterrence against major rivals like Russia and China. The Ministry of Defense points out that the multinational nature of the F-35B helps spread the costs, with the United Kingdom contributing a total of £13.7 billion for 48 aircraft through 2025. Officials maintain that it offers unparalleled 5th-generation advantages, far outweighing any concerns about dependence due to its proven combat effectiveness in tests.